All right. Good evening, everybody, once again. So I hope I'm clear. Thank you very much, Harpreet, for reaching me out for conducting a quick discussion on Linux. I'm going to tell you something about Linux in depth, and this will be for next 45 minutes. I'll not bore you. I'm sure about that. And one thing I would like to convey everybody out here who is listening, Linux is something that you all must know. If you know operating system, that means you should know Linux. They are not different actually. For me, Linux is operating system is Linux. I do not have much difference between these two. So we need to understand some of the very fundamental, very important things from Linux that I'm going to teach you today. I'll show you demonstration so that you can understand. I'm going to do that with Ubuntu. Before I go in depth into the demo part of it, let me first define what is an operating system. Most of you would be knowing the definition. You would say that it is an interface between the user and the computer or something like that. That could be the traditional definition that we have been hearing for past 50 years. But we can make it very, very simple. An operating system is something which is a resource manager. That's all. We have brain, right? Everyone has. If we are not having brain functioning, what is it called as? It is called brain dead. Am I right? So why do we call it brain dead? Very simple. It cannot manage the resources in the body. I cannot understand what happens to my body. I cannot understand who is signaling to me, who is talking to me, who is touching me. Nothing will be understandable, and it's almost like death. So we call it brain dead. So who is your manager here? The brain is the resource manager which manages all the resources in your body. So brain is the operating system. Simple. So likewise, every machine, your phone, your laptop, your computer, whatever you have will have an operating system because it has to manage all the resources in your system. Simple. So why do we have to manage it? Very simple. It has to manage it so as to provide the best of the service possible through that resources. When you open the laptop tomorrow morning, if it is asking you for 2 more GB of RAM, how good will you feel? You might not feel it as very nice, right? It will never ask. Whatever you have already will be used and it will manage with it. If your laptop says that I need another monitor screen immediately with me, otherwise I will blow myself, what will you do? It cannot happen, right? So what is it? It is all about managing resources. I'm going to manage the resources very nicely with operating system, and we have multiple operating systems in picture, out of which Ubuntu is the best. I mean, Linux is the best that I'm going to talk about. Well, having said that, sir, why should I learn Ubuntu? Ubuntu is, or Linux is the base for most of the operating systems, so please understand that. Without you understanding Linux completely, I don't think you can become a good device driver developer. You cannot become an embedded systems developer as well. It needs a lot of understanding of Linux when you go deeper into the software industry. So I have been here for past 15 years, so we live with Linux. Linux is like our kidney, heart, liver, everything. So make sure that you guys understand that very clearly. Well, having given you the introduction, it's time for me to go ahead and to start showing you something as a demo, which you will definitely like and which you will definitely understand. And I'm going to launch my Ubuntu first. Okay, so I have got Ubuntu 20.04 installed in my machine as an application in Windows. So I did not install it separately. I'm repeating it. I have installed Ubuntu as an application. So how do you do that, sir? Very simple. You can do that with ease, and I'll tell you that as well. So I hope you can see my screen. Harpreet, could you please confirm? Can you see me? Okay, right. I hope the font is also visible clearly, and this is all Linux for you. That's all. So I have installed Ubuntu as an application 20.04. The latest version is available in my machine as a Windows application. That's all. You can install it. It's available in Windows Store itself, and it's going to be very easy. But understand one thing: everything is file in Linux. Everything. You are a file. I am a file. File is a file. Input is a file. Output is a file. Error is a file. Everything is a file in Linux. So you need to first understand what is a file. A file is nothing but collection of data. A file system is nothing but collection of files. Sir, what do you mean, sir? I'm going to talk about file system first, and then I'll show you what are all the file systems that are available in Linux, and it's going to be very, very easy for you. File is nothing but collection of data. You can have a simple C file where you will have contents which can be compiled and which can be run. That's a file. That's a C file. You may have a text file. You may have any file, Python file for that matter. You can have anything, any file like that. And what I mean is file is nothing but collection of data. But what is file system, sir? File system is nothing but group of files. I'll tell you what it is exactly. Now, if you see here, the Linux all starts with this backslash. I'm going from the scratch. What is this backslash called as? This is called as mount point. You can see that here pwd is the command for present working directory or print working directory. This backslash is called as the mount point. This is where everything starts in Linux. Sir, what do you mean by that, sir? Very simple. The entire Linux is mounted here. All what you see here, bin, dev, home, lib, lib64, media, opt, root, whatever you see here, these are all called as file systems. Remember, the file systems are all mounted under the mount point, and the mount point is called as this slash. That's all. So how do I go to the slash, sir? When you put cd space backslash, you are into the mount point and you can access the file systems. That's simple, isn't it? I hope it is understandable. Now, what is the next thing that you need to understand? Very simple. I'm coming back to the home directory. Wherever I am in when I'm logging in, it's called my home directory. You can see that home Sriram KV is displayed. Now, we need to understand the types of files available in my system. When I do an ls hyphen, you can see that I do a just ls. ls is listing. But when I do an ls hyphen lrt, it gives me much more detailed content. L is long listing, T is with time frame. So we get everything in a detailed manner. So what are all the files available here? What are all the types of files available here? You can see that here all these blue color thing are all preceded with this D. D shows that it is a directory. So I can see that here Sachin is a directory, D3 is a directory, L1 is a directory, India is a directory. And all these RW, RR, RW, RR, RW, XRR, something like that, all these which starts with read write, they are all simple files. You can see that 1.txt, 2.o. I'll tell you what is the 2.o a little later. Hold on now. 2.c, 2, all these are nothing but the files. And whatever you see as green in color, if you see this green in color content, they are called executable files. You can see that X will be available here. X, X, X. This X is for the user, I mean the owner. This is for the group. This is for others. So we give execute permission to all the three kind of users in Linux. Now this green colored thing is called as executable file. So the first is a normal file. This is an executable file. This is a directory. As you can see, all the D content preceded here are all called as directory. And we have got something called as links. What do you mean by that, sir? You know shortcut, right? In Windows, you keep a shortcut to the desktop and you access that file directly, right? That is called as a links. We have got a link type of file available also. It can be soft link or hard link. Soft link is just like keeping a shortcut in the desktop. Hard link is keeping the copy of the file in a different place. That's like copy paste. You delete the source, destination will still be there in hard link. You delete the source, the destination won't be there with respect to soft link. Soft link is like keeping a source connect in the just keeping a reference point. It's like a pointer in the desktop. That's all. And we have got socket types of files. Socket is like networking content, which you must be knowing right now. If not, we can see if I can cover it up in this session. If not, we can discuss that later. These are all the types of files, the directories, the normal files, the links, the sockets, pipes. All these are the files that we need to know. These are all the types of files. Is it clear? Harpreet, am I audible? Is it understandable? All of you? Perfect. 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 Right. If there is any glitch in between, let me know. Okay. So that I can correct it. Right. Now, what is the next step, sir? I have told you what is a file. I have told you where we need to go ahead to see the file system. But now it is time that we need to see the file systems in detail. What are all the types of file systems, sir? Very simple. I have already shown you that we need to first navigate into the place where the file systems reside. What do you mean by that, sir? Very simple. I'll show you that. We need to first go into the mount point. This mount point is where all the file systems reside. And as I told you, here is where all our file systems are available and we can go to each one of them. What each one of them is all about, sir? Bin is nothing but binary. CD bin. I can go into it and see that all the commands that we are typing are all available here. This is nothing but the binary files for all the commands that you are typing in Linux. You can see that sudo, su, sem, sync. All these are commands. SSH. You must have seen all these commands when you tried it in the lab, right? So you could see that here all the commands, cp, cpan, everything is available here. And this is the place where your complete executable files, even user created executable files, the commands for the users, the system administrator commands, everything could be available here. And this is where you can see all the commands binary files, which means if you want to type something as a command, for example, ls, that ls will be available inside this place as a binary file. So this binary is a collection, ban is a collection of all the related files which are nothing but commands. Now you understand file system. File system is something which has got collection of related files together. That's all. Now all the commands are collected together and they are put in a box called as ban. Simple. Now what is the next file system that we are going to look at? I hope the screen is clear. The next one we are going to look at is boot. All the boot related, when the Linux starts, it is going to start with this boot. VM Linux is the name of the file which will start working on the moment. I do not have access here since this is just an application, but when you have Ubuntu fully installed, you can see the content of this as well, where you will see the boot files. VM Linux would be available there. Now what is the next one that I need to see, sir? Dev, cd dev, and inside this you can see all the device driver files. This makes your devices run. All the device drivers files would be available here, and this is where your complete drivers are available, which lets you run your system. The next one that we need to see is etc, cd etc. What is it? Very simple. etc, all the configuration files, any configuration files that you need to have. It's like control panel, you know control panel, right, in Windows. So just like that, we have got all the configuration files available in this etc. What is the next one that we need to see, sir? Simple. Let me clear the screen. Sorry. Now what is the next one? Home. Home, I told you, it is my home, where I am in, where my files are stored in. You can see that Sriram KV is my home. All my files, all my contents would be available here clearly, and this is easy for you guys to understand, I believe. Now what is the next one that I need to go? Lib. I need to come out and I'm going again to the mount point. Now lib is here. What is lib? cd lib. As you know, the lib name itself tells you it is library files for all the users and programs, whatever we are using. For example, GCC here. GCC is GNU C compiler. So you can see that here. The Git related library files are here. All the library files, whichever you want, Python related files are here. They are all here for all your users as well as you. And the next one that you need to see is there will be something more in your system like lost and found and all. I'll tell you that, but for this, for your initial understanding, this is enough. Lib32, both are of same sort. And the next one that you need to understand is mount, MNT. MNT is the mount point. It is the standard mount point where when you want to insert a pen drive or when you want to insert a CD into your system, it is called mounting. Technically speaking, it is called mounting. So all the file systems will be mounted here, and you could see that CDE are mounted already here. So all these are to be tried. I sincerely request you guys to try it out so that you can understand this clearly. The next file system that we can see is proc. This is a very, very important file system where you have the details of all the processes running in your machine. I'll talk about it a little later in a detailed manner. This is where all the processes, whatever I'm running in my machine now, are all available here, and they are all given with the process ID. You can see that here. I have got a process ID live up and available. So one is the first process which gets launched and it is called as init. The moment I boot my Linux, the first process that comes into picture is one, that is init. Now what next, sir? I'll talk about this proc a little later. We need to spend a more amount of time there. I'll talk about it. Please hold on till then. Next is root. Root I may not have access to. All the root user content, which is your topmost priority, root user content would be available here. And you've got something called as sbin, right? This is very specific for system administrator and your system. So I will have commands which are related to the complete system administrator content. So you can see that here. So all these will be related only to the system administrators. Now let's come back to business, where you've got TMP. TMP should be available here, right? Yeah, TMP. TMP is nothing but is temporary file. I mean temporary file system. Whenever you want to keep something temporarily, which can be deleted at a later point in time, and you do not have to keep it permanently, you can put it here. And USR is nothing but the place where the files, library stuff, including the header files, they all would be available here. VAR is the place where all the log files, CD, VAR, all the log files would be available here. Your mail content would be available here. I mean, your mail queue content would be available here. Spooling will happen here. So all those are happening here. That's all. The most important file systems are all covered for you. Till now, is it clear? If you have any questions, you can ask me. I'll answer them and then I can go to the next part of it. I hope it is clear till now and I'm not boring you guys. I request you people to type it in the chat if you are understanding, and if you can and if you have any trouble in terms of understanding it, please type it in the chat. I'll answer that and then I'll go to the next one. Is it clear till now? I want yes or no so that I can move forward further. I need a yes or no in the chat. Participants, please. Otherwise, it will be highly monotonous. I don't want it to be monotonous session. Good, thank you. I get multiple yeses and it's clear. Very good. Now, what we are going to do is we are going to learn something very, very interesting. How a file is going to be converted as a process and how are we going to track the process? Simple. How a file is going to be converted as a process and how are we going to track it? Remember, okay. Now, first, for that, we need to write a file. Okay, I have written a file and I'm going to show you that very simple file, whatever I have written. Let's take this 1.c, cat 1.c. You can see this file here. This is, or we can type something new, cat vat.c. Okay, so what I'm going to do is I'm going to type a very simple command here, stdio.h, simple set of commands which will enable me to go ahead with explaining you the process. I'll explain you how exactly somebody can convert a file to a process. /n hello. See the way I've used /n, that's a fundamental programming content that you need to follow. Please format it very nicely without fail wherever you are coding. Now I need to do a control D. Now we have done that. The file name is vat.c. That's available here. Okay. Now what are we going to do? I'm going to compile it. How are you going to compile it? GCC. GCC is nothing but GNU C compiler hyphen C. The input is a C file, so I have put it as C. What is the name of the file? vat.c. That's all. So there are some warnings, forget it. Now I have got the file vat.c converted to vat.o, which is nothing but the object file. Is it clear? I have compiled the file with the command gcc. GCC is GNU C compiler. Hyphen C tells that the input is a C file and the file vat.c is taken and is converted as an object file right now, and that's what we have seen just here, vat.o. Can I see that? Can I read that, sir? You can try, but you won't understand anything out of it because this is what is called as machine understandable content. Okay, now I have converted it as object file. Now what is the next step? I need to convert it as an executable file. How do I do it? Only then you can run it, right? The process of linking happens now. You must have studied about the term linker in your studies for sure. In your operating system or in your C programming, you must have studied about the linker loader content. Now what I'm going to do is I'm going to link it gcc -o. Why I use o here? Very simple. I use o here because the input is an object file now. I have an object file ready, right, which is compiled right now and ready for me. So I'm going to give object file as an input. Now I need an output file. The output file is the executable file. I can give any name. Sachin is the name of the executable file. vat.o is the name of the object file. Oh, I have already got some directory by name Sachin. So I'm making it Sachin1. What I'm giving is very simple here. GCC is the command GNU C compiler. -o tells that the input is a .o file and the final output that I need to generate is Sachin1. That's all. Now if you see that there are some mistakes. Why? Let me see that. One second. Where is the mistake? I made it as print. It should be printf, right? Some of you should have told me. I will just copy paste it and we can see how do we run it again. It is just print there. It has to be printf. That's the mistake. Copy. Now I can paste it. We will go to the, instead I can retype it better. I'm sorry. This is the problem with command prompt. stdio.h. We'll redo it, no big deal. Int main. Somebody should have told me here on watching it. I would have corrected the mistake. Printf /n Sachin, return 0. That's all. Now it is over. Now what I'm going to do, I'm going to do the same step. I'm going to compile the file gcc-c vat.c. Now it is compiled. No warning you can see because of that here. Because of the warning only we should have corrected it. We didn't do it. Now I'm going to generate the final executable file Sachin1 from vat.o. Now it is generated. Now what happens is we need to see if Sachin1 is available here. This is green in color and this is an executable file. You can see that xxx is here. Now we can run it. /Sachin1. Now you can see that the output has come. Now what did I do, sir? Very simple. The file vat.c is the one which is converted as an executable file Sachin.1, and when I ran it as /Sachin1, it became a process. Now this is a process. When you run it, it becomes a process. Sir, I cannot understand. Very simple, I'll explain you. This is a file. You compiled it. You got an executable file. The executable file is run this way. You are running it. The moment you run it, it becomes a process. Sir, I cannot still understand. I will show you in a better way. Sachin ampersand, if I put, you can understand. See, Sachin1 it has to be, I'm sorry. Sachin1, I am using an ampersand. This ampersand will give you a number here. This number is nothing but the process ID. So when you put an ampersand, this is run in the background and you get the process ID. You can now track this process if it is alive and running. This is not alive because we have closed it. We have put a return 0. This is printed and this is all done. Now what we are going to do is, I am going to use another example where I will show you how to keep the process alive and how to run it. That's what I'm going to show you right now. Let's see if I have a file available for it. Otherwise, I can type it for you. cat1.c. Yes. Now see this. This is a very simple file which I have taken. You can see that here. Include stdio.h, int main, and inside that Tamil is great. I have printed while one. What is this while one? Can somebody tell me? This while one is something which will go ahead and make you run this code forever. While is infinite. Am I right? While is called infinite loop. So this process will keep running forever. That's the reason I did a while of one. Sir, why do you have to put it, sir? Very simple. For me to analyze a process, the process has to be alive. If you are to be tested by a doctor, you have to be alive. If the doctor tests you after you are dead, it means it is postmortem. I do not want to do a postmortem. Instead, what I need is, I need to check when the patient is alive. So for this guy to be tested, for this process to be tested, I need to keep this process running in the background. So I kept a while of one. It can be for loop, it can be while loop, it can be any loop for that matter, which can keep it running. Now what do? I'm going to run it. gcc-c 2.c. I hope the name of the file was 2 only. We will verify it once more. Cat2.c. No, cat1.c. Yeah, the file name is 1.c. gcc is nothing but GNU-C compiler -c 1.c. So what we are doing, we have generated the object file 1.o. You can see that here the object file is generated. Now gcc -o 1 space 1.o. I am generating an executable file by name 1 by giving 1.o as input to gcc. This means the O option tells the compiler to accept 1.o as input and to generate the final file by name 1. This is called linking. The process of linking it with all the available library files happen here and you get the final output. Now, when I have to run it, I need to do this way. Now this process is running in the background. You can see that we have got a process ID. Sir, what is this all about, sir? Don't worry much about it. I'm going to show you where to go and how to track the process and all those details. Now we have run the process in the background. That's what I have shown you right now. Now we need to go to mount point, cd space \, and in that we have got something called as proc. So cd proc, and in that, as I told you, we have got a lot of process running, and the process which I ran some time back had a number called 189. I hope you remembered that and you can recollect that number. Now cd 189 I can do. That's all. What I did, I wrote a C file. The C file had an infinite loop. It kept running the process. I ran the file in the background by putting an ampersand. I got a number. The number was 189. It is nothing but the process ID. The process ID is now navigated into, I'm getting into the proc file system and I'm getting into 189. That's all. 189 is the process which represents the file that you have converted as a process and you have run it. It is currently running. That's why you are able to see it. If the process is not running right now, you will not be able to see it. Sir, what is there inside this, sir? It will be very interesting set of information. You can see that here. This all content define the process. All these content define the process. For example, if you take FD is nothing but the file descriptor. CD, FD you can do, and you could see that the list of file descriptors that are connected to this process. What do you mean by that, sir? 0 is representing standard input, 1 is representing standard output, 2 is representing standard error. If you have a new file, it will get a number 3. If you have another file, it will get a number 4. So all the files related to your process are all tracked by this file descriptor table, and the file descriptor table is available under 189, which is your process ID. Sir, what is this dabba called as, sir? This box called as? This is called as process control block. You must have studied it. This is called as process control block. This is where the entire information about your process is all available. Some of the information you may not be able to access because of your restrictions, but you can try to access them if you have privileges. You need to have privileges like admin privileges and kind of content. In that case, you can access it. For example, I am going to see if I can access cat stat. This gives you the statistics. You need to go in depth into it to understand what is this. 189 is the process. This is run for the first time. The only process which is running right now is this under this particular file. This is in running status. R says it is running. So these are all the information which could give you stats about how much memory does it occupy, when did it start. All this information could be available inside this. Now when I go to cat stat em, you will get more details about this process. So you can open anything on this and you can start getting details about that particular process, but this goes into a much detailed level and you need to have definite knowledge about it. Without having knowledge, you will not be able to understand. So how will I know all this, sir? Sir, you are telling this because of experience. Yes, that's purely because of experience, but you can learn all this in a much easier way. I'll tell you how exactly to do that. You can learn that with man page. Man page is something which is going to help you in a tremendous way. Man page is superb actually. If you want to know how to use man page, you can type man. Man is manual page where you get complete details of all the commands. Whatever you want, you can get it here and it's going to be very, very useful. You can see that here. So if you want to understand what is man cd, for example, it's not there. Okay, man ls. Yeah. The complete detail about the ls command with the options, whatever I have been using, ls-a, ls-A, all these options will be available here and you can see that. Sir, man I do not want, sir, I want a smaller option. You can use what is. What is, if you use, it is a one line option to understand what the command is all about. For example, what is man, if you put, it will tell you what all the one line, just a one line interface about, one line detail about that particular command will be what you will be getting. Is this clear till now? Did you understand the way a file has been converted to a process and how do they track the process? I'll repeat that once again. Please listen to it carefully. We have been running a process by name 1.c and it became 1, and that 1 is what is being run here. I have not yet closed it. So I can see that ps is the command called as process status. Process status, when you put, you will get the list of commands which are list of things which are running right now. 1 is the command, 1 is the process that we have run. So 1 is related to the process ID 189. So to understand what all the process which are run, you can put ps. ps-al will give you more details. It can even give you hidden process. So I can see that here. It will give you the details about the status. It is running currently, suspended, running. So I can get all those details. And the command is 1. 1 is the command that I created. It is like Sachin, Dravid, something like that, right? I created. Priority I have got here. PPID is nothing but the parent process ID. So I've got a process, this process has got some parent, and the parent process ID is available here. Niceness is the priority, so it may take more time for me to explain you all those, so I'm skipping it for now. But understand that you can clearly track a process which are running in the machine through PS, and after that you can go to mount point, where in the mount point you've got something called as proc, and in the proc you can go and see what all the process currently running in the machine, and you can go into that process as well, CD 189 for an instance, and in that when you open, what you get is called as the process control block, and inside that each of this you can open if you have privileges and you can understand. For an instance, I can open something called as COMM CD FD. If I put, I can understand the file descriptor table, so it talks about all the files. As I told you, I have opened it and I have shown you step by step. I hope till now it is clear. Is it clear, children? I was a little faster, but anyways, I have to go that way, otherwise it will be boring. I need responses, please. Is it understandable till now? I need more response, friends, please. Otherwise, it will be like a very, the session has to be interactive. Right, any questions till now, children? If you have any questions, you can ask me. Then I can go to the next one quickly. No questions till now? Is there any questions? You can type it. I'll be happily answering the questions. All right. Now what I'm going to show you is last topic probably. So what I'm going to show you is how to create soft link and hard link. This is something very important and a very important interview question indeed. So what do I do is I'll first make a directory mkdir v80. So I've created a directory called as v80. You can see that here v80 is created. It is blue in color, and D is what is available here, which shows that it is a directory. Now I'm going to have soft link and hard link. First let me have a soft link. So I have a file called 1.c here. This 1.c is available here, but I want a soft link in v80. So this 1.file is a physical file which is available in the directory home/sriramkv. But what I want is I want it in home/sriramkv/v80. v80 is a directory which is available here. How do I do it, sir? Very simple. ln is the command. ln is link, ln-s. So which is the file that you want? 1.c. I am in the same path, so I did not give the full path. Now where do you need to keep it? sriramkv/v80. When I do that, I would have got the soft link created inside v80. You can see that here it is a soft link. The first letter is L, which shows that it is a link file. So this 1.c comes from this 1.c which is available elsewhere. So if I remove that, this won't be available. As simple as that. Do you understand? So this is called soft link. This is one of the types of the files. So you can create soft link easily with ln-s, right? So if you just give ln, now what I'm going to do is I'm going to create hard link, which means I'm going to create a copy. Let's take another file, 2.c we can take. ln 2.c. Where do you want to keep the copy? Home sriramkv inside v80. Now if I go and see into the v80, I would have got this file as a copy. You can see that here. This first one, whatever I have told you is a link, but whatever I have here, 2.c, is an individual file. Even if I delete the 2.c which is available outside, this file will still be there. This is called hard link. Please remember it. This is a very important interview question. Overall, whatever I have conveyed you today in this 40 minutes is very simple. I told you what is a file. A file is nothing but collection of information. A file is still a file as long as you compile it and you bring it as an executable file. An executable file is also useless because it will not be loaded into RAM until you run it. When you run it, the executable file becomes a process. The moment it becomes a process, it will be allocated with the process ID and you can track it. How do I track it? I can track it via the process control block which is available inside the proc file system. What is a file system? A file system is collection of files and they are all grouped properly, and you can see it under the mount point cd // and inside that you got all the file systems listed, and I explained you most of them very clearly and you can try it out. But all of these may need access, and whatever I have done here is with a very simple Ubuntu, which is Ubuntu 20.04, which is installed as a simple application. You can install it easily in your machine as well and try it out. In case you have any questions, you can ask me, I can help you. And meanwhile, I have typed my YouTube channel where I have taught all these in detail. The entire Linux system programming is taught in my channel in a very detailed way. You guys can go through it, and in case you have any questions, you can always reach me. I have also given my email ID for your reference. If you have any questions, you can email me and I can answer that as well. So overall, I think it was interesting.